yesterday we learned, well, or some of us reviewed, some of us learned for the first time, depending on what our 6th or 7th grade experience was. We reviewed what absolute value was. Today, we're going to learn what an absolute value equation is. So why do we go back and revisit the 7th grade? Because the topic we're learning about today is related to that topic. Okay, so we are going to solve some equations that actually have absolute value in them. And please make sure that you write down everything that I am writing. So example number 1. If I were to read what this says out loud, I would say the absolute value of 2x is equal to 12. So if I were going to say that out loud, I would say the absolute value of 2x is equal to 12. Now, remember what absolute value is? We talked about it yesterday. Absolute value measures distance that a number is from 0. And can you have negative distance? Can you have negative feet, negative miles, negative inches? No. There's no such thing as a negative length of distance. So because of that, and for those of you guys that like to color code while you're writing, that's why you've got all the highlighters and stuff. You don't have to do what I'm doing, but I find it kind of helpful. But what I'm writing in blue, you definitely need to write, even if you choose not to color code it, because it's an important topic about, you don't need to wait for me, but thank you, sir. I appreciate you. Okay? Because of the way absolute value works, what's the absolute value of positive 12? 12, yep. What's the absolute value of negative 12? 12, okay? So 2x, so what's inside that absolute value? Could be 12 or it could be negative 12. Because the absolute value of 12 is 12. The absolute value of negative 12 is also 12. So that means that 2x inside of those absolute value bars, it could have been a positive 12 or it could have been a negative 12. Because the absolute value of either one would be a 12, okay? So that means, and this is true for 99, I don't want to say all, but I'm going to say most. We never say all because frequently all is what gets us. Because 2x could have been a 12 or a negative 12, you have to solve absolute value equations. So what makes it an absolute value equation? It's those bars on either side. And again, if you don't want to color code, that's okay. But what makes it that absolute value equation? It's that one right there. Okay, it's those bars on either side. 2x could have been a 12 or it could have been a negative 12. So every absolute, well, I shouldn't say every, 99.9% of absolute value equations, you're going to have to solve twice. You're going to have to solve them more than one time. And I'm going to give you guys just a second to absorb that because I see a couple of you guys that are still writing. So I'm going to give y'all just a minute. So make sure you've got that learning target on there. If you don't want to color code like I'm color coding it, that's okay. You don't necessarily have to be a visual person like me, but I find it helpful. So because that 2x could have been a positive or a negative, we're going to have to solve it twice. So the good news, friends, is you're not doing anything that you don't already know how to do today. You are literally just solving equations, and you're going to start off just by solving basic one-step equations at that. The only new step we are throwing into the mix is the fact that you're going to have to solve it twice. Is it okay if I scroll up? Anybody got any objections if I do? So let me show you how you're going to set it up twice. There's one version. As an educated math teacher, I really should know why somebody decided to call it case one, but I don't know. why they call it a case. So we've got to solve it for a positive version. So that means we're going to do 2x is equal to positive 12. So you've got to solve that equation twice. We've got to solve it for a positive version, because remember we just said that it could have been a positive 12, but then we also said it could have been a negative 12. So we have to solve it for the negative version as well. So every absolute value equation that we're going to do for the next week, actually, you're going to have to solve it for a positive version, and you're going to have to solve it for a negative version. I had a really excellent math teacher who kind of helped me to remember this. This is the only part that's new today, guys, is just the setting it up. The doing it is you already know how to do it, okay? I had a really great math teacher who explained to me one time, to figure out how to set it up. So imagine, if you will, that like the 2x is sitting there like stuck inside of those bars. So imagine 2x is in jail, okay? Because, we're behind, typically we've heard the expression behind bars in jail, right? Okay, 2x gets out of jail, okay? Hopefully what happens is, so 2x is still the same man that just got out of prison, okay? Hopefully he's able to find a job. Maybe he was able to get his education while he was in prison. Hopefully he's got a support system. He's got a family. He's got loved ones. He's got friends that are going to support him. 2x, he's still the same out of jail. Hopefully he has a positive outcome. Hopefully he's going to be able to just get a job. Things will go well for him after he gets out of prison. Unfortunately, if you're somebody who has some firsthand experience with this, you might know a lot of the time that's not what happens, okay? Same man getting out of jail, and I know I'm being sexist right now because I know women go to prison too. Same folks, 2x is still the same guy. But a lot of the time your circumstances determine how things go for you. An unfortunate reality is that even though you've paid your debt to society, people will discriminate against you because you have a criminal record. Maybe you weren't able to get your education. Maybe you're going home to not a home. You don't have people that are going to support you and help you once you get out of prison. So exactly the same two guys getting out of jail. The bars are gone now, right? But unfortunately, things could go good. You could have a positive outcome, or things could be a negative outcome. There's two different ways. But oh, yeah, go for it. You can look. So it could have gone two different ways. So the only thing that you are learning that is new today is how to just set up the two equations. You're going to take the equation, you're going to take off the bars. So whatever was inside of the absolute value bars, the 2x in this case, is going to stay the same. But you have to solve it for a positive outcome, and you have to solve it for a negative outcome. So the only thing that is new today is that you're going to solve each equation twice. So you're not doing anything that you don't already know how to do. So now if I want to solve my positive version, 2 is sitting next to the x. Is that adding, subtracting, multiplying, dividing? What is that? Multiplication. How do I cancel out multiplication, friends? I divide. So guess what? This part is still exactly the same, okay? What I do on one side, I have to do on the other side. So x could have been equal to 6. Now I got to solve my negative version, okay? So I'm going to divide both sides by 2. X also could have been equal to negative 6. So there's actually 2 answers for every equation you're going to do today. You're not learning how to do anything new except set it up, and the fact that you're going to have to solve them for a positive number and set it equal to a negative number and get 2 different solutions. That is the only thing new that you're going to do today. The other thing that you do need to know is that in math class, when you have more than one answer for the same problem, there's a way we represent those 2 different answers. I suck, and I do mean suck, at drawing this particular symbol. So I'm going to literally Google the symbol and show you what it's supposed to look like, because I can tell you right now, mine isn't going to look anything like that. I've been trying since I was in high school to draw a bracket that looks like this. My Algebra 2 teacher used to get really irritated at me because of how ugly mine was. Sorry, now I'm 44, I still can't draw it. But now let me give you a picture of what I'm trying to draw. This is what I'm trying to draw when I'm trying to do the answer, okay? Because that is not what it's getting ready to look like. And I'm going to scoot that off to the side so you can see what you're going for, and then you can laugh at me when you see what I get. Okay, so you're going to write your answer. Write that down. Yes, ma'am, because you're going to run into some picky teachers that are going to be pretty particular about the way you write it. So again, keep in mind, I'm trying to make the curly braces. This is what I'm trying to do. It's not going to happen. Okay, so you do the little curly Q braces. You do the smaller answer, and then the larger answer, and then the curly. And my right curly Q brace is even worse than my left-handed one. I told you. I know myself. It's bad. But that's what I'm trying to draw. Okay, so how am I going to write those two answers? You're going to say -6, because -6 is smaller than +6. And, yep, I told you it's bad. Okay, so, and unfortunately, parentheses, you know how in math, unfortunately, we're kind of picky, right? What does it look like if you put your answer like this? What? It looks like you're trying to graph, right? Your X and your Y coordinate with the parentheses. So that's why we can't use that, okay? Me too, and who cares, boo? It's all right. It doesn't have to be perfect, okay? So now let me prove to you that that really is going to be the solution. So if we do absolute value, you don't need to write this part in green. I'm just going to show you. Okay, so I'm going to take the first solution. What's 2 times -6?
What's it called? Jesus. Whatever it is.
-12, thank you. What's the absolute value of -12? 12. What if I do, instead of 2 times -6, I do +6? What's 2 times +6? 12. What's the absolute value of 12?
12. See, that was a trick question.
So see how you take both answers and substitute it in there, and it makes the equation true. So because absolute value could have been a positive or a negative number, that's why you have to solve each of them twice. So what's inside the absolute value bars does not change. A lot of kids think, oh, I need to make it like positive or whatever. You don't need to do that, okay? Are we okay if we go to one more example? Anybody okay if I don't scroll up? Okay. I didn't hear any objections. So we're going to do one more because I don't feel like we need to do a ton of these. So the absolute value of x plus 5 is equal to 17. So the absolute value of x plus 5 is equal to 17. So again, because of the way absolute value works, x plus 5 could have been a positive 17 or a negative 17. It could have been either one. So we're going to have to solve this equation both ways. Example 2, boo. Okay, so x plus, case 1, outcome number 1, the first scenario. X plus 5 gets out of jail. Hopefully they're able to find a job, get their education. They have a good support structure. And they have a positive outcome. So it's going to be equal to a positive 17. Unfortunately, the reality of the situation is, frankly, the same guy, x plus 5, is out of jail. He's the same man, but his circumstances might be different. Nobody will hire him because of his criminal record. He doesn't have a family to, take him in. He doesn't have a place to live. And unfortunately, there could be a negative outcome. You solve them exactly the same way you've been solving them for years, honestly. What operation is sitting there with the x that needs to be canceled out? Plus 5. How do I get rid of a plus 5? A minus 5. So I'm going to subtract 5 from both sides. And that's going to give me x is equal to 12. Solve it exactly the same way for case 2. It's just that I'm going to get a different solution because now I'm not doing positive 17 minus 5. Now I'm doing a negative 17 minus 5. But the idea is still the same. So we've got x is equal, what is that, negative 22? Yep. So you're not doing anything new except for this part right here. It's literally the only new part. So for those of us that are still kind of struggling with one-step equations, this is great practice for you because you're basically going to take every equation and you're going to practice solving it twice. The only new part is simply the fact that you got to do it twice for a positive version and a negative version. And for those of us that have this room, you have a class kick. The thing that was different is we just set it up for positive 17 and negative 17, but solving it was still the same. Okay, on class kick.
Like we gotta solve it twice, right? So how would you set that equation up?
So first one on the handout, b over 10 is equal to 2. So absolute value of b over 10 is equal to 2. So
how would I go about solving this? You want to take a shot? Whatever b is, if I divide it by 10, it should equal 2. So it's showing me division. So my inverse operation of division is
okay. So how am I going to set it up real quick? What do I do for my case 1? B over 10 is equal to what? 2. To 2, right? And then how else do I need to set it up? B over 10 is equal to negative 2. Awesome. Yep. All right, and so then like Coach just said, so what is that? Add, subtract, multiply, divide. What is that? It's division, which we're going to solve by multiplying. You're correct. So we're going to multiply both sides by 10. So that cancels and leaves me with b is equal to 20. But then remember, you got to do the other side. You got to multiply both sides by 10 as well. So on the other side, we'll have b is equal to negative 20. How are you going to type it into class kick? First of all, do you guys know where the button is to do the squiggly buttons? It's right next to the P on your keyboard if you're using class kick to check. So it's like to the right of the P button. So if you type it in there, it would be curly Q braces, negative 20, positive 20.